Hello, I welcome you all to this another interesting screencast, and the problem reads replace the loading shown by an equivalent single resultant force and specify the x and the y coordinates of this line of action. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. Right, first things first, let's assume and then we are going to correct it. So let's say it's going to be positioned somewhere there in the y. We have this, and then let's maybe somewhere there. Again, this is just an assumption. This is an assumption. This will be corrected as we find the correct solution. All right. There we go. Let's clean it up. That one does not clean. Something like this. So we're saying this one here is our position there. Again, that is just an assumption. That's an assumption. We'll correct it. So let's create some spaces. We clean it up so that the line does not look right, something like that. Great. So let's assume we have our resultant there. I mean, in the x in the z direction. Let's call this as our FRZ, and then let's call this one here. This one let's call it dy, and then this one dx. Great. So with this information, then let's write down the equations. Right, so the moment being produced by RZ times dy should be equal to the summation of moments due to the forces about the x-axis. And the moment being produced by RZ by dx, okay, should be equal to the summation of moments about the y-axis. And then summation of forces in the z going up in our reference. We are saying this is going to be equal to FRZ, which is equal to what we have. We have a minus 100. What else? We have a minus 200. What else? We have another minus 100 and a minus 200. How many? 1, 2, 3, 4. Great. So when we sum up these 100, 100, 200, so this gives us a 600 newtons. Writing it the other way, we can write this as 600 newtons with an arrow showing to say it's pointing down. Right. So we have that. What we need now is to find the moments, summation of moments in the x and in the y. Summation of moments in the x is going to be equal to, our reference is the right hand thumb rule. Okay, so there we go. Summation of moments about the x-axis. This 100 on the right is going to cause a negative moment, right? A negative moment. And then the rest of all the other forces on the left, they'll cause a positive, right? So we have a negative, just one negative, and the rest are positive. So let's go ahead. So negative 100 times the lever arm about the x-axis, the lever arm is 3, and then the rest are all positive. Then we'll say plus that other 100 on the left. The one we are dealing with is this one that gives us a negative. Now we are dealing with this one that gives us a positive. 100 by, what is the lever arm there? That's a 3 also, right? It's a 3. And then we have plus 200. What does it give us? A 200. This one is a 1. It's a 1. Then we have the other 200 on the far end, which is also the lever arm 1. So what does it give us? Okay, let's grab our calculator. Minus 100 by 3 plus 100 by 3 cancels, plus 200 by 1 plus 200 by 1. Alright, so we have a 400 positive 400 Newton meters. Great. Then let's find the other moment about the y-axis. These ones here, okay, these ones are going to give us positive moment, while the other one 200 on the other end to give us a negative. All right, so these are giving us, all of us, a positive moment. So it will be 100 times the lever arm 3, and then the other 100 times the lever arm 3, and then we have 200 times the lever arm 2, and minus 200 times the lever arm 3. This is going to be equal to, this is 300, 600, 1000 minus 600, that is 400, right? Let me check it out. 100 by 3 plus 100 by 3 plus 200 by 2 minus 200 by 3, 400. We have the same moment. Wow, this is interesting. Great. Let's now import our equations. Let's import them. There we go. We imported the first one, FRD. Again, you need to check. Again, here we need to be mindful of the sign. The sign on the left must be equal to the sign on the right? And the one to guide the sign is this summation of moments, because we found that value already. So summation of moments about the y-axis is positive. Therefore, if that is positive, 600, we need to look at 600. 600 we found. Of course, we do not know its location yet. So if it is a positive summation of moments, therefore we are going to say 600 will also be positive times, which is FRZ times dx, then which is going to be equal to 400, and therefore our dx is just going to be equal to 400 divided by 600. So this gives us a 0.67 meters. All right, so let's pick another one. We import another one, which is that one. It is also positive on both sides, summation of moments about the x-axis. So we'll have a 600 times dy equal to 400. Therefore, our dy will also be equal to 0.67 meters, right? So let's now redraw this. Alright, again, it is very important to make sure that we have the same direction on the left and on the right. Okay, the moment on the left, as we placed our resultant equivalent force, it should give us was similar sign or direction on the left, which is equal to on the right. So we have similar expressions here. We have the same moment mx and my, and we have the same moment arms dx and dy, the dx and the dy. Right. So using the right hand thumb rule, let's start with the y. So where do you think the resultant will be placed for us to have a positive moment about the y-axis? Do we place it here? All right, or do we place it this side there? Which one? Between 1 and 2. Where do we place it for it to have the positive moment about the y-axis? Again, use the right hand thumb rule. So which one do you think is going to give us a positive moment? It is 2. It is 2, right? So it is this one. All right, is that fine? What about in the other case here? Let me rub this. What about for us to have a positive moment about the x-axis? Where about, do we place it here? Sorry, or do we place it here? We are talking about moment about the x-axis. So let's call this 1. Let's call this 2. For it to give a positive moment, where do you think we are going to place our resultant force? Again, use the right hand thumb rule. Which one is going to give us a positive moment between 1 and 2 is what? 1. Great. So we have to place it that side. All right, is that fine? Great. So since we've determined that, so now let's begin to draw. So there we said we're going to place it this direction. I'm using black. Okay, something like that. Something like that. All right. Oh, great. So we have determined the first position for moment about for us to have a positive moment about the x-axis. I mean about the y-axis. Let me extend it a little bit like so. All right. There we go. And then there we said we could place it there. Okay. I'm going to place it there. All right. There we go. Okay. Okay, there we go. There we go. All right. Okay. There we go. Something like that. So let's place our resultant. Our resultant will be there. Need the thick line to be there like that. Okay, there we go. There we go. There we go. And this is going to be equal to, let's write it down, is FRZ is equal to, this is equal to 600, right? 600 newtons. And then here we have dx, then here we have dy. So our dx as a magnitude, again please, this is as a magnitude, is equal to 0.67 meters, and dy is also equal to 0.67 meters. All right, if you check about the x-axis, 600 will cause a positive moment, and about the y-axis it also causes a positive moment. So this looks okay and this is fine. So this is really about it. And I hope the video is helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.